Hello everybody, and this is Mr. Hensley's algebra class, and the date is August 10th, 2020, and today we are going to be in Unit 2. We are going to start Unit 2. We are moving on from Unit 1 and starting Unit 2. Now, in Unit 2, we are going to take what we learned about mathematical processes from Unit 1 into starting to analyze linear functions, equations, and inequalities. Now, today, we are going to focus on more of the graphs and analyzing the types of graphs we have today with linear functions. So we will get to the functions and equations and inequalities later, but today will be about the graphs. So what's on today's menu? We are going to be talking about domain and range. And when we talk today, be sure to keep in mind that this is only linear equations and the linear section we are talking about. So can anybody tell me what characteristic about a linear function looks like on a graph? What similar trait does a linear graph have that all of them share? Take a minute, pause the video, and let me know. Okay, and drum roll, the answer is a straight line. A straight line will always coincide with a linear equation. We will never have any curves or angles or abrupt movements from linear graphs. It will always be a straight line. And remember, if the graph is continuous, it will go on for forever, which means the infinity sign right here will be used in the domain and range. Now, if it is discrete, that could mean two things: that we have dots on our graph plotted, that if we were to connect them, they would form a straight line, or if we do have a straight line and we have endpoints, that is also a discrete linear function. So keep that in mind when trying to find the range and the domain. Getting into how to apply. Now that we are all on the same page as to what this function looks like on a graph, we will now dive into the behavior of this line, the domain and range, and the numbers that coincide with the straight line. So, we will also be talking about how and when to use some of these examples in real life and how they apply to the real world. So, after we discuss and go over all of the functions or the characteristics of the domain and range, we will show you examples and also real life examples of how that can be incorporated into your daily life. So what is a domain and range? The domain and range is just where the line of the graph goes to or ends at what point. Now that last part is very important, as we see the graph goes to or ends at what point, because they will be different. Those are different characteristics when we talk about discrete and continuous. If the graph keeps going and we see an arrow, or we don't see a specific endpoint, it will be continuous. If the graph ends and we can see where it ends and at what point it ends, then that will be a discrete function, and we will have a real number and not infinity in our domain and range. So the difference between the domain and the range is that the domain is only looking at the x-axis, which means when y is 0, or the line running from left to right when y is 0, that will be our domain and what we are looking at. The range is vice versa. When x is 0, it is the line running up and down when x is 0, and that is our range. Just remember, the x-axis is the domain and the y-axis is the range. So here are some examples. I want you to look at these graphs and start with this one and I want you to pause the video and go through all 4 of these graphs and tell me if they are discrete, continuous, and pause the video and get back to me. Okay, since you should have decided whether these are discrete or continuous, we're going to go over them. This one with the purple dots, this one will be discrete, because even though these dotted lines, they would form a straight line and they could go on for forever, they do not. They have specific endpoint. They don't even have a line. So this would be a discrete linear equation, which means that our domain and range would have specific points to them, and it would not go on forever. This, however, this is a continuous function, linear function, because we see the straight line and we see the arrows on both sides. So that means our domain and range would be the same in negative infinity to infinity. This is very similar to the first equation right here, being discrete, and we see that the line, there would be a straight line if they were connected, but it's not, and we can see where it ends, so it is discrete. This, however, this would also be a continuous function because we do not see where it ends. We have to assume that since there's no endpoint, that it is continuous and it will go on for forever. Okay, so let's get into some real-world examples. We will use what we learned in Unit 1, figuring out what is the independent and dependent variables in the situation. Remember, the independent is going to be the x-axis and the dependent will be the y-axis, which will help us with our domain and range. So if Johnny started at 0 minutes and in 10 minutes managed to gather 5 items from the grocery store, what would the domain/range, and is it discrete or continuous? Pause the video and we'll go over it after you pause. Okay, so when talking about the independent variable, we always said that when time was in order, there would always be our independent variable. So starting at 0 minutes, that would be our starting domain, because this is our x-axis, and our end domain would be 10 minutes, because we don't go past that. We don't go less than 0. And then our range would be the items, because this is our dependent variable depending on the minutes. So we would start at 0 items for the range, and we would end with 5 items. And it is also discrete because we have endpoints and we can see where it ended. The next example is if we were to take a study of one of your classmates for the rest of their lives to see how many meals they ate every day for the rest of their lifetime, what would be the domain/range if they ate 3 meals a day for the rest of their life? So this is a linear equation because this is a constant increase, right? 3 meals a day. So the only thing is, this is where it gets tricky. This is continuous because we don't know how long the life of this student is going to be. So we have to assume that it's going to go on forever because we do not have an endpoint. So the only endpoint we have is at 0 because they cannot live negative days, correct? So our domain and range would be 0 to negative infinity, and same for the range because both we are increasing in days and increasing in meals every day. That is all. Next time we are going to be talking about getting into those equations and how to translate them into the graphs. So be ready for that next time. Y'all have a good day. Bye-bye.